Before we expand our services to start running across a bunch of nodes and all of the services talking to each other, let's go over a couple of new concepts that Swarm brings to the table. The first one is a new networking driver called Overlay. And you really just create a network like you're used to creating it, Docker network create, and you put in a -- driver overlay. And what that's like, it's basically creating a swarm-wide bridge network where the containers across hosts on the same virtual network can access each other kind of like they're on a VLAN. This is only for intra-swarm communication. The overlay driver doesn't play a huge amount in traffic coming inside, as it's trying to take a holistic swarm view of the network so that you're not constantly messing around with networking settings on individual nodes. You can also enable full network encryption using IPsec, where it'll actually set up IPsec tunnels between all the different nodes of your swarm, but it's off by default, really just for performance reasons. When you create your services, you can add them to no overlay networks or one or more overlay networks. It really depends on the design of your application. You know, a lot of traditional designs would have the databases on a backend network and the web servers on a front-end network, and then maybe you would have an API between the two that would be on both networks or something like that. And you can totally do that in Swarm. So let's see this in action. What I'm going to do is I'm going to show you what it would be like if we deployed the Drupal example from a previous assignment with the Postgres database as services, and then created an overlay network for them to talk to each other. So first we need to create a network. So Docker network create. And this hasn't changed for Swarm other than the fact that we're going to use a new driver. I'm just going to call it my Drupal. Okay, so I'm going to do a Docker network ls. And you'll see I've got a new overlay. The ingress one is there by default. And you'll also see a new one because of Swarm, which is actually an outgoing network that we don't need to mess with. Okay, so let's create our Postgres service. Docker service create name. We'll just call it pSQL network. We're going to connect it to the my Drupal network. There's actually tab completion on the network names. And then remember, I need to add in that environment variable for the Postgres password, so we can connect to it later. And then we're going to use the Postgres image. Looks good. You'll notice here that we don't get the whole image downloading and all that because services can't be run in the foreground because they have to go through the orchestrator and scheduler. So we can do a Docker service ls, and we can see that one of them is running. And if we do a Docker service ps pSQL, we can see that this is actually running on node 1. So I can do a Docker container logs pSQL, and then I can see the logs of that. Yep, looks like it's running. All right, so let's create our other service. So I'm going to call it, I'll just call it Drupal. And we also need to attach it to that same network. And then we want to publish the port 8080 like we did with the Docker run command. And we'll use the Drupal image. Okay, we can see that it's starting there. There's a trick. You can actually use the watch command in Linux to watch. It'll basically, what it does is it's rerunning a command over and over again. It's installed by default on Ubuntu. So if you just put watch in front of the Docker service ls, it will keep running it every 2 seconds by default until, see, now we have one by one. All right, and I just can Control C out of that. And we can do a Docker service ps Drupal and see that Drupal is actually running on node 2. We have the database running on node 1. We have the Drupal website running on node 2. And so how do they know how to talk to each other? Well, using the service names. So if I paste in one of the IP addresses, it should come up on the Drupal install. And if I tell it the database here, database name, we're just going to do the Postgres. Again, Postgres, my password. And for the host, just like when we were with Compose, and we made the service names in the Compose file, here we're going to use the service name that we created for the database server. And so that was pSQL. And this screen is basically telling us that it's able to talk to the database across the nodes and set up the system. And that's the great thing about overlay, is it really just acts like everything's on the same subnet. All right, so we don't need this anymore. I'm going to finish up this example real quick just to show you the next cool thing about Swarm. Okay, now this site is running, but I have 3 nodes, so how do I know which node it's going to be on and which port I need to make sure that my DNS points to when I create this website name? Well, in my case, I have 3 IP addresses, and I can copy all 3 of them and put all 3 of those IP addresses in. And, oops, I got the wrong one there. And so if you see, it appears like the website is running on all 3 nodes because I'm looking at all 3 IP addresses. But if I go over here and do the service ps Drupal, I know it's only running on node 2. I can even do a docker service inspect and see that, yep, indeed, it's only got 1 IP address on that overlay network right here. So why is it responding on all 3 hosts? Well, that leads us to our next new feature. So that little bit of magic wasn't actually magic, it was the routing mesh. And the routing mesh is an incoming or ingress network that distributes packets for our service to the tasks for that service, because we can have more than 1 task. Now, this actually spans all the nodes, and it's using kernel primitives that have been around a while, actually, called IPVS. So we're not talking about some fancy new service, we're really just talking about the core features of the Linux kernel. And what it's really doing here is it's load balancing across all the nodes and listening on all the nodes for traffic. There's a couple of ways we can talk about how this works. The first example is from one container to another. If our back-end system, like let's say the databases, were increased to 2 replicas, the front ends talking to the back ends wouldn't actually talk directly to their IP address. They would actually talk to something called a VIP, or a virtual IP, that Swarm puts in front of all services. And this is a private IP inside the virtual networking of Swarm, and it ensures that the load is distributed amongst all the tasks for a service. So if you can imagine, if you had a worker role in your application and it had 10 different containers, you don't have to put a load balancer in front of that. This does that for you. When you're talking about traffic from one service inside your virtual network talking to another service inside your virtual network. And the second example of how the routing mesh works is external traffic coming into your swarm can actually choose to hit any of the nodes in your swarm. Any of the worker nodes are going to have that published port open and listening for that container's traffic, and then it will reroute that traffic to the proper container based on its load balancing. What this means is when you're deploying containers in a swarm, you're not supposed to have to care about what server it's on, because that might move, right? If a container fails and the task is recreated by the swarm, it might put that on a different node. And you certainly don't want to have to change your firewall around or your DNS settings to make that container work again. So the routing mesh solves a lot of those problems by allowing our Drupal website on port 80 to be accessible from any node in the swarm. And in the background, it's taking those packets from that server and then routing them to the container. If it's on a different node, it'll route it over the virtual networks. If it's on the same node, it'll just reroute it to the port of that container. And we didn't have to do anything to enable this. This was all out of the box. So let's see a diagram of how this might work. If I created a new swarm service and I told it to have 3 replicas, and it created 3 tasks with 3 containers on 3 nodes. Inside that overlay network, it's actually creating a virtual IP that's mapped to the DNS name of the service, right? And the service by default, the DNS name is the name of the service. So in this case, I created a service called my-web, and any other containers I have in my overlay networks that need to talk to that service inside the swarm, they only have to worry about using the my-web DNS. And the virtual IP properly load balances the traffic amongst all the tasks in that service. Now, this isn't actually DNS round robin. That's actually a slightly different configuration, and we could enable that if we wanted to. There's actually an option to use DNS round robin. But the benefits of VIPs over round robin is that a lot of times our DNS caches inside our apps prevent us from properly distributing the load. So rather than fight with our DNS clients and DNS configuration, we're just relying on the VIP, which is kind of like what you would have if you bought a dedicated hardware load balancer. So in the second example, this is actually showing what it would be like with external traffic coming in. This is similar to what we just did with Drupal, where when I created those yellow boxes by creating one service called MyWeb, and it created 2 tasks and applied them to 2 different nodes, each one of those nodes has a built-in load balancer on the external IP address. For me, because I'm using DigitalOcean, that IP address is the one that DigitalOcean gave me. And when I use the -P and published it on a port, in this example, it's using port 8080, any traffic that comes into any of these 3 nodes hits that load balancer on port 8080, and the load balancer decides which container should get the traffic and whether or not that traffic is on the local node or it needs to send the traffic over the network to a different node. And again, this actually all happens in the background without any special effort on our part. All right, so let's see this routing mesh in action. We've already saw the example with Drupal and how it listens on all 3 nodes, but what if we had multiple tasks? Let's see that load balancer working. So if we do a Docker service create, what we're going to do is we're going to use an Elasticsearch container. I'm going to call it search and give it 3 replicas. And I'm going to publish it on port 9200, which is its default port. And in this case, we definitely want the :2 in there because it's the easiest version to deploy right now. While that's creating, I'll just mention that Elasticsearch is actually a search database that's accessible via a JSON web API. So it's really easy to hit with curl and give us good examples of how this works. If I do a Docker service PS search, we can see that it's smartly created each task on a different node. Now, if I just do a curl on my local host on node 1 on port 9200, because I published that port, I'll get back the Elasticsearch basic information. And part of that is it will actually create a random name. That's just a feature out of Elasticsearch. So if I curl this multiple times, you'll see on this one it's patch, the patch server, and then a third time Jane Foster, and then it'll start repeating itself like such. And that's actually the virtual IP acting as a load balancer and distributing my load across the 3 tasks. So a few more notes on the routing mesh. In 17.03, which is the release that I'm showing you this on, the routing mesh and the load balancing are currently a stateless load balancer. So if you've ever dealt with state inside of maybe Amazon's Elastic Load Balancer or other load balancer technologies, you know what this is about. This is basically saying that if you have to use session cookies on your application, or it expects a consistent container to be talking to a consistent client, then you may need to add some other things to help solve that problem. So out of the box, every time you hit a service with multiple tasks, it's going to give you potentially a different result. And also, if you get into the details of this, it's actually a layer 3 load balancer, and that actually operates at the IP and port layer. It doesn't actually operate at the DNS layer. If you've ever run multiple websites on the same port, on the same server, this isn't going to do that yet. You're still going to need another piece of the puzzle on top of that if you're actually wanting to run multiple websites on the same port, on the same swarm. And luckily, that's a pretty common request, and there's several options you can do to solve both of these problems. And one of them is to use Nginx or HAProxy, which there are pretty good examples out there of containers that will sit in front with your routing mesh and actually act as a stateful load balancer or a layer 4 load balancer. They can also do caching and lots of other things. If you need that, you might want to check some of those out in the resources of this section. But I should also mention that if you were to pay for a subscription of Docker Enterprise Edition, with it comes something called UCP or Docker Data Center, which is a web interface. But I should mention that Docker Enterprise Edition, if you get a subscription to that for your Swarm nodes, it actually comes with a built-in layer 4 web proxy that allows you to just throw DNS names in the web config of your Swarm services and everything just works.